I'm Edric. Today I'll walk you through my implementation of the Valura.AI microservice. So my core philosophy for this build was simple. Protect the user from unsafe financial guidance and protect the system from unnecessary LLM cost and latency. So let's look at how a request flows through the system. So when a user submits a query, it first passes through a rule-based safety card. This runs in under 10 milliseconds and blocks harmful or unsafe financial intent deterministically. Next, the query hits an in-memory LRU cache. If you have already seen the exact same query, we bypass the LLM entirely and return the classification instantly from the memory, reducing both latency and API cost. If it's a new query, we make sure it goes to the intent classifier, which uses a single Gemini LLM call to extract structured entities and determine which agent should handle the request. The router then maps that intent to a deterministic agent. For example, if the portfolio health agent analyzes the user's holdings, fetches live prices using Y Finance, and compares portfolio performance against a benchmark like the S&P 500. All of this is streamed back to the user in real time using a server sent events, so the system feels responsive even while processing. The most important non-obvious decision I made was adding mutation safe caching directly into the routing layer. In a high traffic system, repeated queries can significantly increase cost and latency. So I implemented a per process LRU cache. When a query repeats, classification latency drops from seconds to sub-milliseconds. The key detail is the use of copy.deepcopy. When returning cached results. Since Python objects are mutable, returning a reference could allow downstream logic to modify the cached data. By returning a deep copy, I ensure cached results remain isolated and consistent across requests. I was also told what would I do if I had another week. So maybe if I had another week to work on this project, I would make sure to do these two key improvements. First, I would replace Y Finance with a production grade market data provider like Alpaca or Polygon. While Y Finance works well for prototyping, it isn't reliable enough for a high scale financial platform. Second, I would move the in memory cache to a distributed Redis layer. This would allow multiple service instances to share cached results, significantly improving performance and reducing API costs at scale. So let me just demonstrate the system. So here you can see the system streaming classification, routing, and final response in real time. Even if the LLM fails or times out, the system falls back to a rule-based classifier, ensuring it never crashes. To summarize, the system is designed to be safe, cost-efficient, and resilient under failure, while remaining easy to extend with additional agents. Thank you.